Hello, in this lecture we'll find out the area of a square. In the drawing we have a right triangle ABC. We know that side AB equals to 5 units in its length, side BC equals to 12 units in its length. Inside this right triangle ABC we have this square DEFG. And our mission is to find out the area of this square DEFG. So first of all, we will implement the Pythagoras theorem on the right triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse in the right triangle ABC is AC. Therefore, the square of the hypotenuse is AC squared, and it must be equal to AB squared plus BC squared. So in the right triangle ABC, by PT is a version from Pythagoras theorem. According to the Pythagoras theorem, in the right triangle ABC, AC squared must be equal to AB squared plus BC squared. So AC squared, it is the square of the hypotenuse, must be equal to AB squared. AB is 5, therefore AB squared is 5 squared, that is 25. Plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 144. So found out that AC squared equals to 25 plus 144 is 169. So AC squared equals to 169. We take a root of this equation and finally we get that AC equals to the square root of 169, that is 13. So the length of the hypotenuse of the right triangle ABC, the length of the hypotenuse AC is equals to 13. Okay, so I write it down in the drawing itself that AC equals to 13 units in its length. AC equals to 13. So in the right triangle ABC, we define this angle ACB as alpha. So in the right triangle ABC, the sum of the angles must be equal to 180 degrees. Therefore, this is angle alpha, then and this angle equals to 90 degrees. The missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. So the missing angle here equals to 90 degrees minus alpha. So we define 90 degrees minus alpha as beta. So the missing angle here equals to beta. Here, if 90 degrees minus alpha equals to beta, if we add to this equation alpha and we subtract beta, we get that 90 degrees minus beta equals to alpha. we have also the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So the hypotenuse AC, it is absolutely a straight line. So if you focus on the lower side of the hypotenuse AC at point D, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. The sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the lower side of the hypotenuse AC, on the straight line AC at point D? We have this angle that is equal to 90 degrees plus the missing angle. In total they must be equal to 180 degrees. Therefore the missing angle here must be equal to 90 degrees in its size, according to the rule that I mentioned. Likewise, if you focus on the lower side of the straight line AC at point E, here the sum of the angles must be equal to 180 degrees, therefore the missing angle here must be equal to 90 degrees. So in the right angle GEC, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha, according to our definition, equals to beta. Therefore the missing angle here must be equal to beta. So if we focus on the upper side of the straight line BC is the side of a triangle, it must be a straight line. So if we look at the upper side of the straight line BC at point G, here the sum of the angles must be equal to 180 degrees. So beta plus 90 degrees plus the missing angle must be equal to 180 degrees. So the missing angle here must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles on one side of the straight line, or it is the sum of the angles on the upper side of the straight line BC at point G. So the missing angle here must be equal to 90 degrees minus beta. But according to our definition, 90 degrees minus beta equals to alpha. Therefore the missing angle here equals to alpha. So in the right angle FBG, in the small right angle FBG, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle here equals to beta. And finally, if we focus on the right side of the straight line AB at point F, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the upper side, at the right side of the straight line AB at point F? We have this again, that is beta plus 90 degrees plus the missing angle. Here in total they must be equal to 180 degrees according to the rule that the sum of the angles from one side of a straight line is equal to 180 degrees. So the missing angle here must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles on the right side of the straight line AB at point F. So the missing angle here must be equal to 90 degrees minus beta. But according to our definition, 90 degrees minus beta equals to alpha. Therefore, the missing angle here must be equal to alpha. So, in the drawing, we have in total 4 right angles. 1, 2, 3, and the big right angle, triangle ABC. All those 4 right angles are similar to each other according to angle similarity rule. Because of the fact that each triangles has the angles of alpha, beta, and 90 degrees, each of those two triangles, all those four triangles have actually the same angles, alpha, beta, and 90 degrees. Therefore, all the four triangles are similar to each other according to angle similarity rule. Okay, so we define the length of one side of square DEFG as L. So therefore, all the sides of this square DEFG must be equal to L, because all the sides of a square are equal to each other. That is to say, FG equals to L, FD equals to L, and DE also equals to L. We define the length of side BG as X. We know that BC equals to 12, therefore BG equals to BC minus BG. Again, BC, GC, this line GC equals to BC minus BG. So GC equals to BC, that is 12, minus BG, that is X. So GC equals to 12 minus X. So this side GC equals to 12 minus X units in its length. So we know that the right triangle ABC, the right big triangle ABC, is similar to this right small triangle, triangle FBG. Okay, so I write it down. The right triangle ABC is similar, this is the sign of similar, to the right small right triangle, triangle FBG. And because of the fact that the two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that X over L in the small right triangle FBG is equals to, we have X is in front of angle beta, so in the right triangle, big right triangle ABC, side BC is in front of angle beta, so and BC equals to 12, so it will be 12. L is the hypotenuse of the small right triangle FBG, therefore AC is the hypotenuse of the right triangle ABC, that is equals to 13. So in conclusion, we found out that because of the fact that the right big triangle ABC is similar to the right small triangle FBG, the following relationship exists between their sides. X over L in the right triangle FBG is equals to 12 over 13 in the right triangle ABC. Okay, so we will multiply this equation 1 by L, and we get that X equals to 12 over 13 times L. And according to equation 1, X equals to 12 over 13 times L. Likewise, we also know that the right triangle ABC, the right big triangle ABC, is similar to this right triangle, triangle AGC. according to angle similarity rule. Repeat again. Because of the fact that all the four triangles in the drawing are similar to each other, we also know that the right big triangle ABC is similar to this right triangle AGC according to angle similarity rule, and for that reason the following relationship exists between the sides of those two similar triangles, triangle ABC and triangle EGC. Here we will have L over 12 minus x in the right triangle EGC. Again, L over 12 minus x in the right triangle EGC. Will be equal to, here L is in front of angle alpha, so here in the right triangle ABC it will be AB, that is 5. It is also in front of angle alpha, and 12 minus x is the hypotenuse in the right triangle EGC, and the hypotenuse in the right mid triangle ABC is AC, and AC is 13. So in conclusion, we know that because of the fact that the right big triangle ABC is similar to the right triangle AGC, the following relationship exists between their sides. L over 12 minus x in the right triangle AGC equals to 5 over 13 in the right big triangle ABC. Okay, so here we will multiply this equation 2, we cross multiply this equation 2, and we get that 13L equals to 5 times 12 minus x. Again, we cross multiply this equation 2, and found out that 13L equals to 5 times 12 minus x. So we have already found out in equation 1 that x equals to 12 over 13L. Here, x equals to 12 over 13L. So we can substitute x in this equation 2 by 12 over 13 times L. So we'll do it now, and we get that 13L equals to 5 times 12 minus x. And x, according to equation 1, equals to 12 over 13L. Okay. So in this equation 2, we multiply 12 by 13 and then we divide it by 13 in order to have a common factor with this expression. And we get that 13L is equals to 5 times 12 times 13 is 156 minus 12L over 13. So we multiply this equation by 13, and we get that according to this equation 2, 13L times 13 is 169L, and it is equals to 5 times 156 . equals to 780 minus 5 times minus 12L is minus 60L. So in conclusion, found out that according to equation 2, 169L equals to 780 minus 60L. Here we relate to this equation 2, 60L, and we get that 169L plus 60L equals to 229L, and 229L equals to 780. Here we divide this equation 2 by 229, and finally we get that L, that is the length of the square DEFG, is equals to 780 over 229. 780 over 229 is equals to 304.0611 units. That is to say, the length of one side of this square DEFG is equals to 3.40011 units. And we know that the area of any square there is equals to the multiplication of one side by itself. So the area S equals to L square. That is to say, it is equals to 3.40011 square. So, and 3.40611 square is equals to 11.6016 square units. So, repeat again, we actually found out the area of square DEFG, the area that we are looking for, is equals to 11.6016 square units. So, in the next step, I'm going to summarize the lecture. Okay, so this lecture found out the area of this square DEFG. So, in the drawing, we have a right triangle. Triangle ABC is a right triangle. We know that side AB equals to 5 units in its length. Side BC equals to 12 units in its length. Angle ABC equals to 90 degrees. And our mission is to find out the area of this square DEFG. Okay, so first of all, we know that all the angles inside a square are right angles. And here, we actually implemented the Pythagoras theorem on the right triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle ABC, the hypotenuse is AC. Therefore, the square of the hypotenuse is AC square, and AC square must be equal to AB square plus BC square. So here, by PT is the evaluation for Pythagoras theorem. According to the Pythagoras theorem in the right triangle ABC, AC square equals to AB square plus BC square. So AC square, that is the square of the hypotenuse, equals to AB square. AB is 5, therefore AB squared is 5 squared, that is 25, plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 145. So in conclusion, we found out that AC squared equals to 25 plus 144 is 169. So AC squared equals to 169. We took a root out of this equation and finally found out that AC equals to the square root of 169, that is 13. Okay, again we found out that the length of the hypotenuse AC is 13 units. Okay, then we defined this angle, that is actually angle ACB in the right triangle ABC, as alpha. And we have the rule that the sum of the angles in any triangle is equal to 180 degrees. So in the right big triangle ABC, this angle equals to alpha, this angle equals to 90 degrees. Therefore the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. So the missing angle here must be equal to 90 degrees minus alpha. But we defined 90 degrees minus alpha as beta, therefore the missing angle here equals to beta. Okay, and we also have the rule that the sum of the angles on one side of a straight line is equals to 180 degrees. So if we focus on the lower side of the straight line AC at point D, here the sum of the angles must be equal to 180 degrees. So 90 degrees plus the missing angle in total must be equal to 180 degrees. Therefore the missing angle must be equal to 90 degrees. Likewise, the sum of the angles in the lower side of the straight line AC at point E must be equal to 180 degrees. So which angles we have at the lower side of AC at point E? We have this angle that is equal to 90 degrees plus the missing angle in total must be equal to 180 degrees according to the rule that I mentioned. Therefore the missing angle must be equal to 90 degrees in its size. So in the right triangle EGC, this angle equals to alpha. This angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees it is equal to 180 degrees, that is the sum of the angles in any triangle. So the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta according to our definition. Therefore the missing angle must be equal to beta. If 90 degrees minus alpha equals to beta, it means that 90 degrees minus beta equals to alpha. So if we focus on the upper side of the straight line BC at point G, the sum of the angles here must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line BC at point G? We have this angle that is beta, plus this angle that is 90 degrees, plus the missing angle in total must be equal to 180 degrees according to the rule that I mentioned. So the missing angle must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees it is equal to 180 degrees. That is the sum of the angles in any triangle. So the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha. Therefore the missing angle equals to alpha. So in the right small triangle FBG, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle equals to beta. Then we focus on the right side of the straight line AB at point F. At the right side of the straight line AB at point F, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have the right side of AB, of the right side of the straight line AB at point F? We have this angle that is beta, plus this angle that is 90 degrees, plus the missing angle in total must be equal to 180 degrees. So the missing angle here must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha. Therefore the missing angle here equals to alpha. In the right triangle AFD, in this right triangle AFD, this angle equals to alpha. This angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. but 90 degrees minus alpha equals to beta, therefore the missing angle equals to beta. So in the drawing we have in total 4 triangles. 1, 2, 3, and the big triangle ABC. So we have here 4 right triangles, and the angle on each triangle, the angles in each triangle are alpha, beta, and 90 degrees. Therefore, all the 4 triangles are similar to each other according to angle similarity rule. Okay, again, all the 4 right triangles in the drawing are similar to each other. Why? Because they have the same angles. Okay, so that is to say, the right big triangle ABC is similar to this small right triangle FBG. Again, the right big triangle ABC is similar to this right small triangle FBG according to angle similarity rule. And because of the fact that the right triangle ABC is similar to the right small triangle FBG, we can derive from that fact that the following relationship exists between their sides. That x over L in the right small triangle FBG equals to 12 over 13 in the right big triangle ABC. Repeat again. From the fact that the right triangle ABC is similar to the right small triangle FBG, we derive that x over L in the right triangle FBG equals to 12 over 13 in the right big triangle ABC. So this is equation 1. We multiplied equation 1 by L and found out that x equals to 12 over 13L. Then all the 4 right triangles are similar to each other. Therefore, the right big triangle ABC is similar to this right triangle AGC. Again, the right big triangle ABC is similar to the right triangle AGC according to angle similarity rule. I repeat again, the right big triangle ABC is similar to the right small triangle AGC according to angle similarity rule. And from the fact that the right triangle ABC is similar to the right triangle AGC, we derive that the following relationship exists between their sides. We derive that L over 12 minus x in the right triangle EGC equals to 5 over 13 in the right triangle ABC. Repeat again, we derive that all L over 12 minus x in the right triangle EGC is equals to 5 over 13 in the right big triangle ABC. Here we cross multiply this equation, equation 2, and found out that 13L equals to 5 times 12 minus x. We already found out in equation 1 that x equals to 12 L over 13, or 12 over 13L. So we can substitute x in this equation, equation 2, by 12 over 13L, because x equals to 12 over 13L. We did it and we found out that 13L equals to 5. Inside the brackets we have 12 minus x. And x according to equation 1 equals to 12 over 13L. So we substitute x in this equation 2 by 12 over 13L from equation 1. And here we open the brackets on this side of this equation, equation 2, and found out that 13L equals to, before we open the brackets, we multiplied 12 by 13 and then we divided by 13 in order to have a common factor with this expression. So 12 times 13 is 156 divided by 13. So after we multiplied 12 by 13, we divided by 13, we found out that 13L equals to 5, and inside the brackets we have 156 minus 12L over 13. We multiply this equation 2 by 13 and found out that 13L times 13 is 169L. Here we open the brackets. We have 5 times 156 is 380. And we have also here 5 times minus 12L is minus 60L. Okay, minus 60L. So in conclusion, found out that 169L equals to 780 minus 60L. Here we added to this equation 2 60L and found out that 169L plus 60L is 129L. So 129L equals to 780. We divided this equation 2 by 229 and finally found out that L, that is the length of one side of this square DEFG, L equals to 780 over 229. 780 over 229 is equals to 3.40011. In conclusion, we found out that one side of this square, L, is equals to 3.4001. And we know that the area of any square equals to the sides, one side squared. One side, the length of one side squared. That is to say, the length of the area of this square DEFG will be equal to L squared. And L squared, L is 3.0011, therefore L squared is 3.0011 squared. And 3.40011 squared is equals to 11.60 or 11.6016. So actually found out that the area of this square DEFG is equals to 11.6016 square units. Okay, thank you very much.